Hello everyone, I'm Sashank. I'm from College of Engineering, Indiana University. I'm here to present a paper, News Categorization using Hybrid BiLSTM-ANN Model with Feature Engineering. It is co-authored by Soumya Sanakavarapu and Dr. S. Chitrakala. In this section, I will give an introduction as to why we chose BiLSTMs and why we chose feature engineering. So what is the need for digital management system? There is an exponential increase in the number of articles across different topics which are published in media. Users would prefer if they can find relevant topics of discussion based on articles of their interest. Websites display news articles often sorted by categories for the convenience of user. Categorization of news articles help in suitable storage and management of wide varieties of articles. So what is BiLSTMs? BiLSTMs are a particular type of neural models which help to persist information in both forward and reverse directions. And that is, a particular BiLSTM model will be able to predict what is the word which will occur next or before a particular location within the sequence. So we use feature engineering also along with BiLSTMs. Feature engineering helps increase the attributes available in a dataset, thereby enabling better modeling of data. So we go with two different types of features, hypernyms and hyponyms. Hypernyms help in generalizing the base word into a category, which is a kind of relationship. Hyponyms are the inverse relation of hypernyms with respect to the base word. They help to establish a higher morphological relationship between the words and help to determine linguistic association. In this section, I will deal with the methodology. So we go with the hybrid categorization model, where words and sentences are preprocessed and vectorized by using a BiLSTM model, whereas the features which are extracted are vectorized and preprocessed and fed into ANN models. The number of ANN models depends upon the levels of hypernyms and hyponyms which we choose. If we go for example, if we go for level 3 hypernyms, then there will be 3 ANN models. If we go for level 3 hyponyms, there will be 3 ANN models. So there will be a total of 6 ANN models along with the BiLSTM model. So this is the working of the categorization model. The sequence of input words are converted into a word embedding vector by using an embedding layer. So for example, each word in the corpus is converted into an n-dimensional vector. If there are W words, the embedding vector is a matrix of W star n values. The hypernyms and hyponyms are given as weighted embedding matrix to the ANN. The outputs of the BiLSTM network and the ANN network is given to another level 1 ANN, which tries to optimize the weights of the hidden layers by reducing the losses of prediction. This creates a semantically aware recurrent neural model. By combining the different levels of hypernyms and hyponyms together with words, it is possible to resolve linguistic conflicts by usage of words via word sense disambiguation. We create our own data set by collecting news articles from different categories such as business and economy, entertainment and sports, criminal and legal matters, lifestyle and fashion, political matters, science and engineering. We have a total of 3,000 files, which are 500 files in each of the 6 categories, and a testing data set consists of 500 files with 100 articles in each category. Dataset pre-processing. First, we go with organization, stop word removal, parts of speech tracking, and then we perform with feature engineering by using WordNet from NLTK. We can see that we have gone with 10 levels of hypernyms as well as 5 levels of hyponyms. And we then split the data structure into words, levels of hypernyms, and levels of hyponyms. So for example, we can see that the words can be fed into the BiLSTM model, whereas hyponyms are split into level 1 to K, each of which will be fed to a particular ANN model. And hyponyms are split into levels 1 and K, and each high level of hypernym will have its own ANN model. So this way, a complex correlation between the contextual structure and the meaning of the words are achieved. Sequential inputs for INSTM model is performed by using Keras tokenizer, which converts the sentences of the articles into sequences to capture the semantic structure of the articles. The sequences are padded up to a certain length to make the inputs uniform for the BiLSTM model. Sequence length is taken as the average length of all the sequences in the corpus. Vectorization. The words of the articles are converted into sequences by using word embeddings to ensure that the model understands the semantic formation of the articles. The contextual representation of the words is needed to determine the similarity, and the size of the corpus is limited. So we go with skipgram to build the embedding vector. Once we create the embedding vector, we can then create something called a TF-IDF map. TF-IDF score is the ratio of number of occurrences of a word in an article to the number of occurrences of the same word in the entire corpus. We then create a weighted embedding vector by multiplying the TF-IDF score as well as the embedding matrix for each of the words. This helps to represent the subjective similarity of the embedding vector and the objective factor of the TF-IDF map. Then we create different level 0 models, which are then combined together by using a level 1 meta classifier. The first level 0 model is the BiLSTM model. This consists of an input layer whose number of nodes is equal to the sequence of length of the sentences in the corpus. We take the sequence of length to be 80. Then we create an embedding layer which gets the words as a sequential form and converts it into a word embedding matrix. Then we have two bidirectional layers with 128 and 64 nodes. We have one dense layer with 64 nodes, and the output layer has 6 nodes, one for each category. Then we have level 0 ANNs for each level of hypernym and hyponym. These have 7 hidden layers with 256, 512, 1024, 2048, 1024, 512, and 256 nodes. The output layer has 6 nodes corresponding to 6 categories. Then we combine all these level 0 models using a level 1 model. The level 1 model has an input layer which has L plus n star L plus m star L nodes, where n is the level of hypernyms taken and m is the level of hyponyms taken. So, for example, if we take 3 levels of hypernyms and 3 level of hyponyms, and 6 categories are taken, then we have a total of 3 star 3 star 6 plus 6. So that like this, we can calculate the number of input nodes which are required. The hidden layer has 2 hidden layers with 150 nodes each, and the output layer has 6 independent nodes, each corresponding to one of the 6 categories of the news articles. The hyperparameters on the hybrid model is Adams optimizer, binary cross entropy loss function, a learning rate of 0.01, and a batch size of 128. Results and analysis. As we can see, the training model reaches a high training accuracy of 99% for the data set for both hypernyms and hyponyms. The hybrid model using words with hyponyms show reduced performance than the model using hyponyms alone for categorization. This is because hyponyms can include certain complexities which cause the sentence structure to be to be confused. So the comparison of the testing accuracy with various levels of hypernyms with plain text. Since we have decided that hypernyms alone attribute a more contextual meaning, we vary the levels of hypernyms along with the plain text. It can be seen that the hybrid model using level 8 hypernyms with words perform better than other levels of hypernyms, but it has still lower accuracy than plain words alone. And the grouping of level 1, 2, 3 of level that is level 1, 2, and 3 hypernyms together outperforms the individual level of hypernyms due to better classification of words into classes across different categories. The performance of the model is then compared for hypernyms and hyponyms with words over different levels. It is observed that the hybrid model of level 1, 2, 3 hypernyms with words outperforms the other 3 hybrid models with a high testing accuracy of 61.33%. So this can be the categorization confusion matrix of the categorization model for the level 1, 2, 3 hypernyms and hyponyms with words for classification. The categorization is done across 6 classes. The comparison of the performance, we can see that the level 1, 2, and 3 hypernyms with words alone performs better than hyponyms with words alone or hypernyms and hyponyms with words. We can identify that hypernyms actually perform better feature engineering than hyponyms or hypernyms and hyponyms together. This is because they portray a more complex relationship in the form of this kind of relationship rather than hyponyms, which are more of a group kind of relationship. So conclusion and future works, we conclude that we have studied the hybrid BiLSTM-ANN model for different levels of hyponyms, as well as all the 3 together to study the semantic relationship between words and articles to the category. We can see that combining hypernyms alone increase the performance of the classification system rather than using hypernyms and hyponyms, or rather just words alone. Future works would involve named entity recognition, which is a natural language technique to establish semantic relationship between words. The classification system can be further extended to include a recommendation engine that could use the weights obtained from this system for personalized usage recommendation. I would take questions and answers right now. We thank the chairs of CCWC 2021 for granting this opportunity to present our paper. Thank you.